We're finding horizontal asymptotes today. We already found vertical, which is, I don't know, I think it's easier. Now we're finding horizontal asymptotes. So first, we look at the exponents. To find the greatest exponent used in the numerator and in the denominator. In each, the greatest exponent is called degree. And that's what we're going to be looking at. We're going to look at the exponent on the numerator, comparing to the exponent in the denominator, determining the degree. And that's what we're going to compare. So if the degree of the numerator is greater, then we have no horizontal asymptote. Notice that it's a no horizontal asymptote. It's different than 0. Be careful with that. So if the degree of the numerator is greater, then no horizontal asymptote. If the degree of the numerator and the denominator are the same, we're going to look at their leading coefficients. It's going to make more sense when I work out an example with you. The degree of the denominator is greater, then the horizontal asymptote is at the x-axis or y equals 0. Okay, so a few examples. We have this function right here. So you know we're going to have to compare the degree of the numerator and the denominator. So look at the highest exponent right there, highest exponent right there. So the degree of the numerator is 2. Degree of the denominator is also 2. When you compare them, they're the same. So when the degrees are the same, you're going to look at this column right here. The degrees are the same. So you're going to do the leading coefficient right here. The leading coefficient for the numerator is 3. The leading coefficient for the denominator is 5. Therefore, your horizontal asymptote for this function is right at y equals 3 over 5. The next one, we have the degree of the numerator is right there, 2. The degree of the denominator is right there. Since I don't have anything, that means the degree is 1. On top of the x, the denominator, when I don't have anything, I have an invisible 1 right there. So when you compare, I have the degree of the numerator is greater. So when the degree of the numerator is greater, that means I have no horizontal asymptote. So comparing numerator with the denominator. Numerator is 1. Denominator is right there, 2. So degree of the denominator is greater. So the degree of the denominator is greater. That means the horizontal asymptote is right there at y equals 0. Last one, degree of the numerator right there is 3. The degree of the denominator right there is also 3. When you compare, they're the same. When the degrees are the same, we're going to look at the leading coefficients. So the leading coefficient right here is 4. The leading coefficient right here is 2. And we can simplify that 4 over 2 as just y equals 2 for the horizontal asymptote right there. Now we're going to look for horizontal and vertical asymptotes from the graph. So horizontal asymptote goes right there, and a horizontal line is a y equals line, 1, 2, 3, going right through 3. The vertical asymptote goes through right there, and it's a vertical line, so x equals 1, 2, 3, negative 3. Horizontal asymptote on number 2, we don't have one, because if we were to trace that line, we are quite not sure where would that be. So we don't have a horizontal asymptote, so none. Vertical, on the other hand, is pretty obvious. If we were to trace that vertical asymptote, it would go right through -1. So x equals -1. Horizontal asymptote. It's a pretty little line that goes right through the x-axis. So y equals 0. Vertical. X equals 1, 2, 3. One more. Horizontal asymptote. Right there at y equals 0. Vertical. We got 2 vertical asymptotes right there. X equals -2. And the other one goes right through, oh, look at that, +2. So I can just write x equals plus or minus 2, or if you want, you could have written x equals -2, x equals +2. Either way. Last one. Now you have to find all 3 of them. So you have to find domain, vertical, and horizontal asymptote. To find the domain, remember that the domain will be everything, all real numbers, except those numbers that make your denominator equal 0. So we have to factor this. Now we set each factor equal to 0. And we solve for x. So we're going to have 2 restrictions on the domain. So domain can be x is not equal to 0, x is not equal to 4. And the vertical asymptote would go right through x equals 0 and x equals 4. Now, horizontal asymptote, we're going to have to compare the degrees of the numerator with the denominator. So the degree of the numerator is clearly greater. So numerator, degree of the numerator is greater. So since the degree of the numerator is greater, so we have no horizontal asymptote. So none right there.